This integral appears very simple, but it hides a very beautiful solution. So we are going to start off with a u sub, right? We are going to let u to be equal to the square root of the secant of x plus the tangent of x. Right, so let's square both sides, right? So squaring both sides is going to be secant of x plus tangent of x at the right hand side, and now differentiating 2u du is going to be equal to differentiating this secant of x is that secant of x tangent of x plus this is the secant square of x, that is differentiating secant of x and tangent of x, and then dx, and then let's isolate the x, that is going to be 2u du divided by secant of x tangent of x. I'm going to factorize secant of x out, and that will be left with the tangent of x plus the secant of x, like this. So we have the x to be equal to 2u du divided by this one, that is secant of x multiplied by this tangent of x plus secant of x is the same as u squared. So I'm going to replace that with u squared, like this. Alright, cool. Now let's switch colors and look at an identity. So the secant square of x is equals to the tangent square of x plus 1. That is from the Pythagorean identities. So here secant square of x minus the tangent square of x, this is equals to 1, right? So let's write this one as difference of two squares. So this is the same as secant of x minus the tangent of x multiplied by the secant of x plus the tangent of x, and this is equals to 1. Correct. Now we know that secant of x plus tangent of x is u squared, right? So I'm going to replace this one with u squared, which is multiplied by the secant of x minus the tangent of x, like this, and this is equals to 1. So that implies that the secant of x minus the tangent of x, this is 1 over u squared. So now permit me to call this one equation 1 and this one equation 2, right? This one equation 2, correct. So now let's solve equation 1 equation 2 simultaneously for tangent of x and secant of x in terms of u. Now let's do that. So here I'm going to write this equation 1 here. Equation 1 is the secant of x plus the tangent of x, this is equals to u squared. This is equation 1, that is from here, correct. Now let's sum the two equations. When we sum the two equations, equation 1 plus equation 2, what are we getting? Equation 1 plus equation 2. When we sum them, the tangents of x will go, so that is going to be left with the 2 secant of x, and that is equals to 1 over u squared plus u squared. And this is the same as 1 plus u raised to the power 4 all over u squared, correct. So that implies that the secant of x is the same as 1 plus u raised to the power 4 all over 2u squared, correct. Now we can complete the x here, right, in terms of u, so that we take it into the u wall entirely. So the x is going to be 2u du all over secant of x. Now we know secant of x to be this, and that is 1 plus u raised to the power 4 all over 2u squared, and this is multiplied by u squared here, correct. Now let's find an expression for tangent of x in terms of u, that is from here. So to get the tangent of x in terms of u, what you have to do is to subtract equation 2 from equation 1, right? So what I'm going to do here, I'm going to say equation 1 minus equation 2, right? So equation 1 minus equation 2, when I do that, the secant of x are going to cancel, and that is going to be left with the 2 tangent of x, and that is going to be equal to u squared minus 1 over u squared. So u squared minus 1 over u squared, and this is the same as u raised to the power 4 minus 1 all over u squared. So this is the tangent of x in terms of u. So tangent of x is u raised to the power 4 minus 1 all over 2u squared. Okay, now we can take the integral into the u world completely. So the integral I is going to be equal to the integral of the tangent of x, right? So integral of the tangent of x multiplied by this. So the tangent of x, we just found that to be this one. So that is u raised to the power 4 minus 1 all over 2u squared multiplied by the square root of the secant of x tangent of x, which is u. That is our u sub, right? So that is multiplied by u times dx, and dx is this guy. So dx is 2u du all over 1 plus u raised to the power 4 all over 2u squared. 1 plus u raised to the power 4 all over 2u squared, and this one is multiplied by u squared outside here. That is our expression for dx. Cool stuff. Now this is a little messy, so let's try to clean it up. So the integral of u raised to the power 4 minus 1, here u squared is going to cancel u squared here, right? And then we have 2 will also cancel 2 here. Then we have u to the power 4 minus 1 all over u squared here, multiplied by u times u here is u squared, divided by 1 plus u raised to the power 4 all over 2 left here. And u squared will cancel u squared. And then there's du here, I beg your pardon. So this is the integral u raised to the power 4 minus 1 all over 1 plus u raised to the power 4 over 2 du. Cool. So I is going to be equal to multiply top and bottom by 2. That is going to be the integral 2 times u raised to the power 4 minus 1 divided by u raised to the power 4 plus 1 du. This is what we have. And now we can bring 2 out because it's constant. U raised to the power 4 minus 1 all over u raised to the power 4 plus 1 du. Okay, so I is going to be equal to 2 times the integral. Negative 1 here, permit me to write it as positive 1 minus 2. So 1 minus 2 is the same as negative 1, right? Divided by u raised to the power 4 plus 1 du. So now I'm going to split this one into 2 different integrals. The first one is 2 times the integral u raised to the power 4 plus 1 all over u raised to the power 4 plus 1 du, minus 2 times the integral of 2 all over u raised to the power 4 plus 1 du. These are our 2 different integrals. So I is going to be the first one. This one is going to cancel this one nicely. We have 2 times the integral of 1 du minus 2 times the integral of 2 all over u raised to the power 4 plus 1 du. Cool stuff. Now here, this one is trivial. The first one, which I just integrating 1 in the u, which is 2u, minus 2 times the integral of 2 all over u raised to the power 4 plus 1 du. Alright, so the task now is to find the value of this integral. I'm going to call it I1 and switch colors and then deal with that. So I1 here is going to be equal to 2 times the integral of 2. 2, permit me to write it as 1 plus 1, right? Divided by u raised to the power 4 plus 1 du. That is I1. Now divide top and bottom of this integral by u squared. I'm going to do this by brute force. So 1 over u squared plus 1 over u squared divided by u squared plus 1 over u squared du. I'm just dividing top and bottom of this integral by u squared. And now the next step is to add and subtract 1 to the numerator. So you have 1 over u squared. I'm going to add 1 and then subtract 1. The net effect is 0 and then plus 1 over u squared. All this one divided by u squared plus 1 over u squared du. So I1 is going to be equal to 2 times the integral of 1 plus u squared, 1 plus 1 over u squared. And here I'm going to factorize negative 1 out. That is going to be negative into 1 minus 1 over u squared. Like this. All this one divided by u squared plus 1 over u squared du. Now let's split this I1 into 2 different integrals. So 2 times the integral of 1 plus 1 over u squared all over u squared plus 1 over u squared du, minus 2 times the integral of 1 minus 1 over u squared all over u squared plus 1 over u squared du. Cool. Now here, I've done this before in my other video. See that when we differentiate something like this, so let's have d du of u minus 1 over u. This is going to yield the numerator of what? The first one, right? And when I come here, when I differentiate something d du of u plus 1 over u, this is going to yield the numerator of the second one. All right, so that means that in the denominator, I have to get something like this at the denominator of this one and something like this at the denominator of the second one, right? Okay, so now let's do that. So here is the integral I1 is going to be 2 times the integral of 1 plus 1 over u squared all over. This one can be, because I want something like this, right? That is going to be u minus 1 over u. I'm going to square all that. So when I look at this, u minus 1 over u all squared, this is the same as u squared. We are foiling that, plus 1 over u squared and then minus 2, right? So, but there's no minus 2 here. For me to cancel that minus 2, I have to add 2 to the right hand side. For me to nullify the effect, I have to add 2 to the left hand side. So this and this will cancel, then we are left with u squared plus 1 over u squared. So that means I have to add 2 here, so that will be equivalent to the denominator here. Minus 2 times the integral 1 minus 1 over u squared, right? Because I want something like this at the denominator, something like this, I have to write the denominator as u plus 1 over u and all this one squared. And when I look at this, u plus 1 over u all squared, this is the same as u squared plus 1 over u squared plus 2. But I don't have plus 2 here. For me to cancel the plus 2, I have to subtract 2 to the right hand side. And to nullify the effect, I have to subtract 2 to the left hand side. So this and this will cancel. Then you have u squared plus 1 over u squared, which is the same as our denominator. So that means the denominator here, I'm going to subtract 2, as we have seen here. And then du. So these are our two different denominators. And now let's do a substitution. I am going to let v to be equal to u minus 1 over u. And I am going to let, let's say, w to be equal to u plus 1 over u. Now let's differentiate. dv is going to be equal to 1 plus 1 over u squared. And all this one du, right? So that means in place of this, I beg your pardon, so there's du here. So that means in place of this one, I'm going to replace that with dv. And when I come here, the w is going to be 1 minus 1 over u squared. That is the differential. And then du. So in place of this one, I'm going to replace that with the w. So now let's take the integral into the v and the w world simultaneously. So 2 times the integral. This is now dv. That is this guy. All right, divided by this one is v, so that is v squared plus 2 minus 2 times the integral of dw, that is this one is dw, divided by w, because this is w squared plus minus 2. All right, so I1 is going to be equal to 2 times the integral of 1 all over 2 can be written as the square root of 2 squared plus v squared dv minus 2 into, I'm going to multiply the numerator by -1 and the denominator by -1 as well. So that is going to be this minus 2 can be written as the square of 2, root of 2 all squared, right? Like this. And then dw. Okay, so I1 is going to be equal to 2 times the integral of 1 all over the square root of 2 all squared plus v squared dv minus 2 times the integral. It's now going to be plus because this and this will become positive. And then we have 1 all over, reversing this one, that is now going to be the square root of 2 all squared minus w squared dw. Now we are going to compare this one to the tan inverse and the tan hyperbolic inverse integrals. We have the integral of 1 all over a squared plus x squared dx this is the same as 1 over a, the tan inverse of x over a. And if we have something like the integral of 1 all over a squared minus x squared dx, this is the same as 1 over a, the tan hyperbolic inverse of x over a. So we are going to use these ones to solve our integrals. So our integral I1 is going to be equal to 2 times, now solving the integral, we have 1 over what is a here is the square root of 2. Then we have the tan inverse of v over the square root of 2 plus 2 times 1 over a here is the square root of 2, and then here is the tan hyperbolic inverse of w over the square root of 2. So now we have to replace v and w. Go back up. V is u minus 1 over u and w is u plus 1 over u. So we just replace that. I1 is going to be, this is now 2 over square root of 2, and then the tan inverse of 1 over the square root of 2 times v. V is u minus 1 over u, like this, plus 2 over the square root of 2, and then the tan hyperbolic inverse of 1 over the square root of 2 times w, and w is u plus 1 over u, like this. So this is the integral in the u world. I1 is going to be equal to, rationalizing this radical, that is going to be the square root of 2 times the tan inverse of 1 over the square root of 2, and now multiplying these ones is going to be u squared minus 1 over u, plus rationalizing this is the square root of 2 times the tan hyperbolic inverse of 1 over the square root of 2, and then this is going to be u squared plus 1 over u, like this. So now we can go back up, right? So the integral I is going to be 2u minus I1, right? So it's going to be 2u minus I1. So we can just subtract integral I1 from 2u. So I is going to be equal to 2u minus I1, right? So I is going to be equal to 2u minus I1, and I1 is this. So that is going to be the square root of 2, the tan inverse of 1 over the square root of 2 multiplied by u squared minus 1 all over u, and then minus, right, the square root of 2, the tan hyperbolic inverse of 1 over the square root of 2 times u squared plus 1 all over u squared, like this. We are done. We can put the constant of integration, right? But the original integral is in terms of x, but this one is in terms of u. So we just have to go back to what u squared and u are, right? So our substitution, from our substitution, we know that u is equal to the square root of the secant of x plus the tangent of x, and then u squared is the secant of x plus the tangent of x. That is when we go to the very top, right? So when we go to the very top from the very beginning, that's our substitution. U is equals to this and u squared is equals to that, right? So we just replace that in our integral, and that will be the answer to this beautiful integral. Okay, so this is going to be a long one. So we have I to be equal to 2 times u, and u is the square root of the secant of x plus the tangent of x, right? And then minus the square root of 2, the tan inverse of 1 over the square root of 2, right? And then this is multiplied by u squared minus 1. U squared is this, so that is secant of x plus the tangent of x minus 1, that is minus 1 here, and all this one divided by u, and u is the square root of the secant of x plus the tangent of x, like this. And then minus the square root of 2, the tan hyperbolic inverse of 1 over the square root of 2 multiplied by u squared plus 1. U squared is secant of x plus the tangent of x plus 1 all over u squared. This is u, I beg your pardon, so this one is u. I'm sorry about that. So this one here is u. So that is u. I'm sorry about that. So this is u. So u is the square root of the secant of x plus the tangent of x, like this. So we are done, and we put the constant of integration, and this one is the answer to this beautiful integral. Yeah, so that is how I can solve this integral. If you know an easier way to solving this integral, please leave a comment in the comment section and let me know what you think. And if you enjoyed the video, consider subscribing to Calculus Diaries for more engaging content on integrals. I thank you so much for watching this video, and I will see you in the next one. Bye bye.